Hello and welcome back to our mini-series about Java Reflection API, where we try to recreate and rebuild common functionalities that we use in libraries frameworks that are reflection-based. We covered a lot of basics of Java Reflection, like class scanning, annotation handling. So as for today, we will start with the next thing and create our own simple annotation-based validation engine, where you put some annotations on your class, for example, NotNull, max length, pattern, and then you provide your object into some sort of validator implementation. It automatically scans all your fields and performs all the validation checks on its own, returning you a list of violations. So our goal is to recreate same behavior, making our library reusable by introducing a way how user can define custom validation rules and validators. So let's begin. Okay, let's start with the interface that we will try to implement. We will have our object validator that will have one function. Validate. It is accepting any object that we would like to scan for annotations and perform validation on, and it will return a set of violations back if any. So a violation consists of field which is violating and the reasoning text. So if it's like a null violation, I would like to see that so field name is violating, not null. And as always, here we are following the TDD approach, where we want to define our requirements as a test upfront before the implementation, so it's clear what we are implementing for. Starting with the most simple thing that we can and slowly making tests green one at a time. So for example, the most basic case is that if we have no validation rules, there should be no violations. We have a student without any annotations present, so no validation should be performed, resulting in empty set. Let's run the test and see. By default, we have already implemented it because we have returned an empty set in the object validator. So everything is set. Let's start with some simple rule. For example, let's create a not null annotation that will be targeted on field. And then for that, we will define a test again. So we need some sort of structure that has this annotation present to verify. For example, we can create a student that has a name property and it is marked as not null. Then we create an input where we provide our name as null, so violating this rule. In the next section, we perform validations and collect the result. And afterwards, we want to make sure that this violation is present in our set. So let's run the test and confirm that it's failing. And indeed, it's failing, so we're ready to implement it. So last time we saw how we had this large if-else state branching. And overall, it was bad solution design choice because it really wasn't open for extensibility. So now we will start with the extensibility in mind and create a separate validators for each of our rules. So for that, let's create an interface that we will call validator. That will just have one method validate, which will accept some sort of object and will return an error message if present. So optional is a perfect fit here. Optional string validate object. Our interface says following: we will provide an object that needs to be validated, and if there is any violations, we will return it as a string reasoning. If not, we will return empty optional. So let's implement our first validator. Let's have additional package for validators, and let's create NotNull validator, and it will implement our validator interface. And by this we will separate the concerns. We will have single responsible validator that will perform only one action, that they will do a validation, and they will not know anything about other existing validators. They have only one job, is to perform this validation. And having them separate, it means it is easy to add a new one. The logic, I think, it's quite simple. If the object is null, we return an optional of must not be null. And just like that, we have implemented our validator. Now that we have implemented our individual validator, we need to include it in the object validator itself. The main responsibility of the object validator is to take an object, break down it into the fields, and check each field separately if it has these validation annotations present. For example, not null. And if it is present, we need to execute appropriate validator. So let's find class of this object by using object get class. Then we can ask for fields using class get declared fields. Then we need to iterate over each field and check if annotation is present by using is annotation present method. And here we need to provide the annotation type that we are searching for. For example, not null class. So now that we know that field is annotated with this annotation, we need to extract the value, take validator and validate it. So for validator, we know that we need to use our not null validator, and to read the value, we need to use reflection API. So let's create a helper function here that will read the value from field. field and the object instance. Again, what we need to do is to return field get and provide the instance, but we know that it can throw an exception, so let's wrap it into try catch, and let's just catch any generic exception and rethrow it as a runtime exception. And before accessing the field, we need to make it accessible. Then we can extract the value using this new function, provide field and the object. Now we need to run our validator. So validate value, and it returns an optional string. So if there is some violation, it will return a message for it. What we need is to collect this violation into a set, which will later return. So let's define a violation set here. Let's use, for example, hash set. So if the error is present, we need to add this violation to the set. So let's create new violation. So first value was the field name. Let's get field get name. And the second one was the reasoning. We can take this error message. And then instead of collections empty set, we return our violations. Okay, so it's not happy that we have some generic hash set of object. We need to provide that there will be a set of violations. Yes. Let's now rerun the test. And just like that, we have implemented our NotNull check. Now that we have our basic case, let's expand on it and introduce new validation rule. So for example, NotBlank that will check if the value has some characters besides white spaces. Let's start with the test again. Let's have a NotBlank test where we will put a null value first, because on the null value we also need to fail because the value is not present. And we already can define for empty value where we provide many white spaces, and it should return that name must not be blank. As you can see, our tests are copying each other, so let's create some common assertions so our tests are smaller. Let's extract the when and then section. So we will provide the object to run the validation on. Then we will provide field and reason of the failure that needs to happen. Here we run the validation and then assert that such violation is present in the output. And then our test can be simplified just by creating the input and running this function. Same goes for the other case. Let's keep things simple. Tests are failing, time to implement them. So let's create a NotBlank validator, which will accept some value, and we need to return if it's blank or not. NotBlank actually overlaps a bit with our NotNull case. So either we could extend the functionality or just here provide a quick check for the null. So if the object is null, we return an optional of must not be null. Yes, it's a copy of the check, but the validator is self-sustained. We can move it on its own and it will perform. If the object is not null, then we need to check if it's blank or not. But blank means only for strings. So first of all, we need to verify that the object is instance of string. And if it's an instance of string, then we can verify and call the isBlank method. If it's blank, we return our new error, must not be blank. Now that we have implemented our NotBlank validator, we need to again expand our object validator and include it here. So if we would like to follow the common pattern and provide an if statement and check for annotation present, we will end up again with this bunch of if-else statements that actually are not expandable. So if a user would need to add its own custom validation rule, he would need to modify our internal code to include additional branching here. And that's not what we want to do. We would like to run dynamically appropriate validator for that rule. And for that purposes, I would like to actually have some sort of annotation configuration that will tell our code that this annotation needs to be validated by this validator. Let's create annotation that is called ValidationRule, but the target will be another annotation. And inside ValidationRule, I would like to introduce one configuration that is called validator. When we are creating a validation annotation, we actually would also specify the class that would perform the validation itself. And to limit this class not being a wildcard, but some sort of real validator implementation, we will extend it with validator. So it meaning any class that is extending validator can be used in this field. So if we go back to NotNull, here I want to introduce this validation rule and configure a validator for it, which would be NotNull validator class. So by this I'm saying I have a NotNull annotation and it must be validated with this validator. Same goes for the NotBlank. We can define validation rule, provide the validator, NotBlank validator. So by using this annotation, we will be able to distinguish what annotations are counted as validation rule and what annotations are not. And we have some sort of relationship between annotation and the validator that can be leveraged in our object validator. Now, instead of checking for one particular annotation, we need to scan all the annotations and find if any has a validation rule annotation applied to it. For annotation in field get annotations, and here we need to extract the type. Then we can check if this type has annotation present on itself. So is there annotation on annotation? And we are interested in validation rule class. If it's present, it means we have found annotation that should be considered as validation rule. So now we can extract this validation rule by asking type get annotation by validation rule class. We can find out what kind of validator we need. And we can do that by asking the validation rule what is the class that we need. So now that we have a class of our validator, we would need to create an instance which we can actually use to validate our field. And using reflection again, we can create also an instance of a known object given that we have a class. We can find all the constructors and call them. So let's quickly create a helper function that will be of type T. It will create a new instance of this T class. Using class get constructor. So we'll get default constructor and call a new instance on it. Again, it can fail with exceptions. For example, there is no such thing as default constructor, but we want to just suppress it and rethrow it as new runtime exception so that we don't have explicitly to cast. Because if we cannot create a validator instance, we probably shouldn't move on. Okay, coming back. So now that we have the class, we can call this new instance using this class. And because we have specified that this can be any class extending a validator, the validator itself will be with interface validator. Now that we have proper types, we can extract the value again and run our validation that we have previously. And voila, let's quickly recap. So we take all the fields that we have on the object that we need to perform validation on. We go over all annotations that are present on this field, and we want to understand if a validation rule is present. If validation is present, it means that this annotation needs to be used in the validation process. So we need to find the validator. To find that, we extract the validation rule annotation, get the configuration, so the class that we need to use, create new instance, get the value, perform the validation. Okay, now we can rerun the tests and see if we have implemented NotBlank. And indeed, all tests are green. So technically we now have made our things extendable. We now just need to create a new validation rule, add the annotation on it, and provide the validator that needs to be executed. So if user would like to run custom code, he would be able to do that. So let's see how easily we can do that. Let's create an annotation, past or present, that will verify a date time to see if the date is current date or present. But if it's a future date, we need to violate. So we can quickly implement our test, which will check if the date is past or present. We will pass at the now plus 1 day, making it in future. And we expect that there will be a violation on creation date that must be present or past date. So the only thing that we actually need to do is to implement the validator. If the object is local date, then we can collect the current time. So now we need to compare. So if it does not equal date and now is not after the date, and we provide message must be present or past date. Otherwise, we return optional empty. Just for our sanity, let's add 2 additional tests. One that will check for the present date, where we provide the current date and see that there are no violations. And the second one is for the past date, that we provide -1 day and also verify that there is no violation. Let's run the tests. And we can see all of them are green. And just like that, you saw how easily it is to add new validation rules. But now time to address the elephant in the room. So we have not talked about the performance implications. So Java reflection is quite slow. It will create additional overhead to your operations at runtime. It actually can add up and cause some performance issues. Especially all of these scannings for the fields, for the annotations, creating new instances. All of these actions will affect your performance. And if you have large amount of data, this could be one of the bottlenecks in your application. This is why you need to be careful with Java Reflection API and be smart about it. For example, currently we are scanning each object for the annotations and creating instances for it at runtime. And each time we scan the same object, we need to perform same actions again. But does really the validations change for the same type? No. And this is one of the things that we can do with the reflection, is to pre-build something at the startup. So instead of having this always dynamically scanning for annotations and creating instances, we could scan it once at the beginning and reuse all of those validators to perform subsequent validations on the same class. And that's why some libraries prefer to generate a code instead running annotations at runtime and not affect the performance by doing reflective calls. So for example, we can make this object validator class specific. When we create a validator, we provide a class for each it will be used. And we initialize all the validators in the beginning and reuse them for the same type of objects. I want it to be specific for some class. So if I want to validate a person, I want to create a validator for a person. Then I need the constructor where I will initialize all of the validators. So in constructor, we really want to repeat our steps that we do on each validation right now. We want to find all the fields and all the annotations and all the validators that we need. So let's gather fields, then iterate over each field, scan the annotations and find those that are marked as validation rule type. When we have found such, we want to get that annotation and create a validator. And now instead of performing the validations immediately, first we store the validation instance that we have just created. So first of all, let's insert empty list for this field, as we know that we will need to collect them. So if this field is not present, we put an empty list of validators, and then we add additional validator to the map. So now what we have done, we scanned the whole object, found all of the validations and all of the validators, and have pre-built instances during construction time. And so now we can pretty much delete everything. And so now for us, it's much easier to perform the validations because all we need is to get the validators for this particular field. So let's use getter_default, because in case the field does not exist, let's just return an empty list. Now have a list of validators that we need to perform on this single field. Now we want to stream and go over by each validator and perform a validation on this field's value. So get value, field, and object. In result, we will have a stream of optionals. And we want to get rid of the empty ones and only leave the ones that actually contain value. We can do that by flat mapping the stream. Flat mapping means that we can combine multiple streams into a single one and call optional stream function. It will take an optional and create either empty stream if the value is not present, or a stream with single value. So now that we have only our error messages, we can create our violations for this field and provide the error message. Then everything can be actually added to our violations collection that we return. To make things a bit simple, let's create a static builder for it. I always prefer having such factory methods to create objects instead of calling constructor directly. So object validator of type E, let's call it class of. We will provide class E, and what it will do, it will build our object validator and provide this class. If you would like, we could actually now hide this constructor, only allow our builder pattern to be used. What is the benefit of it? Actually, if you really would like to, we could have caching here. So if you're trying to build a validator for the same class, you can actually reuse already existing one. But that's another story. Now going back to our tests, we need to make some adjustments. So here it means we cannot no longer have a generic object validator. We need to have class specific for each test. So I will remove it here. And now here we need to create our instance. So our object validator will be now constructed using this of builder pattern, and we need to provide student class. So we will at this moment construct whole validation tree, and we could perform many validations with single instance. So we will need to add that in a couple of places. So let's add it here again, student class. Now here we have this generic function that we used. We actually can use it. Just instead of student class, we can provide our input get class. So we will build a validation for that input and perform validations. And two more places to fix it here. And it will be a blog post, and same goes here. Blog post. So now running the whole test suite, everything is green, and it's quite good because we have optimized the reflection usage. We use it only once when we create the validator, and then we can reuse for the same type. And just to clean some things up, now that we have parameterized object validator, we know that we will only accept a T as an object to validate. So here, instead of validating a generic object, we can provide a T reference. So it will cause some issues in the test because now we are creating an unknown T reference basically. So here the class does not match the object. And let's make this function more generic. For it, we will need to provide that we're accepting some sort of type T, change the input again to T. Now, here is one problem, that this class is losing the T reference. And that's why we will need to introduce one more parameter and reuse this class as input. So while in the test it looks maybe quite awful to provide both class and the input of the same type and have this just to indicate the type, when we will use in real life the validator, you can see that it will reject values of different types. So if I provide a string, it will say I can only validate a blog post. So small quality of life victory. So now we need to update our tests. Here we need to provide blog post get class. Here we'll provide student class and same things on the top level. Now we can rerun the test. And still everything is green as expected. And okay, so the last thing that we'll do today is add the possibility to add configurations for our validations. Because sometimes we need to provide a configuration for our validation annotations. For example, we have a length that can have a max parameter. So once again, we start with an annotation. We have a length annotation that is a validation rule, and it will be validated by the length validator class. So having this will be automatically picked up by our validation engine. And here I want to provide one parameter, a max length, which will be defaulted to integer max value. So let's quickly define a test where we provide a student with a field that is set to max length of 5. We perform the validation, and if it's violated, we expect to have message must be at most 5 characters long. So we output also the configuration here inside. Now let's implement it. So here we want to start with checking if the object itself is an instance of string. And if it's a string, then we want to perform, for example, the length check. So if the string length is larger than some sort of maximum, we want to return a violation. Must be at most 5 characters long, for example. So I want to have this value to be read from somewhere. So right now we need to have this information read when we are building our validator, because we can have multiple length validators. For that purpose, let's add a new function in our validator that we will call initialize. And here we will provide an annotation inside. So our goal is to initialize our validator by using this annotations information. So we can provide some config, for example length, and we want to extract it during construction time. So now here in our length validator, we can implement this method and actually try to extract this value. We can check if this annotation is instance of length. If it is, then we can override the max value by asking for the configured value. So now we can here update the message to include the max value and remove our hard-coded 5. Now the only thing that we need is to call this initialize, and that we want to do in our object validator. So here, when we are building it, we have our annotation. So here we have our annotation and we have our validator. And when we create this new instance, we actually can initialize it with our annotation. Now the only thing that we need to add these methods for our other validators. as they do not need any configuration, we can just leave them empty. Now we can go to our test and run it and see if this value has been read. And indeed looks like it has picked up the value 5. Let's change it to something like 3 and rerun the test. Yes, and now we have a failure because we expect the message to be with 5, but we can see that 3 is provided a way how we can configure a validator based on this annotation. And again, one more quality of life thing that we can add is actually to have here a type that is extending some annotation. And by this, we could provide already casted annotation inside our initialize function. So it means we are creating a validator for specific annotation, which kind of makes sense. So what does it affect? We can go to our validators and provide here a concrete type, meaning we can remove here this generic annotation with the length and remove this casting. Same goes for NotBlank. We can here provide that this validator is meant for NotBlank, and on the configuration side, we are expecting to get NotBlank annotation. Same goes for the NotNull past or present. So great, we have implemented our annotation-based validation engine. We saw how we can create extendable classes where user can create own annotations and validators that will be picked up by our code. We touched a bit the performance aspect of the reflection, that actual reflection calls are creating overhead. And we want to reduce them as many as we can during runtime because sometimes it could become a bottleneck. So ideally we need to be smart and perform some actions up front. Some libraries actually prefer to compile a code that will be using ordinary methods instead of reflective calls. But for us, we created a validators up front, so we only invoke reflection when we are trying to read a value. We also worked with generics to create a better user experience for our library users by providing types in the method suggestions and limit what they can be applied to. So we're getting closer to end of this mini-series, and next time we will start with Spring-like dependency injection. So if you like such content, please subscribe, leave a like. Your feedback is really appreciated here. So keep coding, and till next time.